Okay, I'm real excited because this is one of my favorite sections, slope-intercept form. It's kind of where everything starts coming together as far as graphing, and it makes your graphing so much faster and so much easier and so much more understandable. So I'm really excited about this. So I'm wondering who should join me. Should it be, oh, I don't know. The butterfly's kind of big, because if I take the butterfly in, butterfly takes the whole space. But I'm so excited, it's like butterfly worthy. Okay, but I'm going to take the butterfly off for right now. Okay, so first we're going to look at some definitions just so that we understand what we are looking at. First we're going to talk about linear function. Linear function. Okay, so linear function. Okay, I need you. Oh, yeah, well, I'm kind of at the edge there. Okay, so with a linear function, hold on, I'm moving away. Don't know if you can tell that. I wonder if I got, like, less loud. That would be great for you. Okay, so linear function. Check this out. Check out how that word line is right in that word, linear function. So what we are looking at here is linear functions are they're equations that create a line. Okay? Equations that create a line. Now, we learned before, we talked about direct variation. Direct variation. Remember when our x and our y increased or decreased at a stable rate, at the same rate, okay? So direct variations are linear equations. They are linear equations. So we were already working with linear equations when we were doing direct variation. Maybe if I bring this out just a little bit, we can get more in there. Perfect. Okay, so let's start with the parent function. Let's talk about a parent function. Parent function. A parent function, let's move this so that you can actually see what I'm doing. A parent function is the simplest equation of a function. I don't know about you, but my parents were a little bit more complex. Okay, but in these cases, parent functions are the simplest equation of a function. So, if we have, basically, we are looking at y equals x. This is a parent function. Now, what is the coefficient with our x? Yes, that's right, it's a 1. Okay, like I couldn't hear any of you. I don't want you to think that I'm actually thinking that I'm hearing you. The bird told me. It's a 1. See, even the bird knows. Okay, so that is the parent function. So this is a linear parent function. Okay, and we're going to grow from there. We're going to, y equals x is the simplest line we can make. Okay, and we'll see what that looks like as we go along. So, linear equation is just quite simply a linear models a linear function. So, linear equation models a linear function. And basically, guys, we're going to come out with a line. It's just going to be a line, okay? So let's move off of this page. Let's go to the next page. And let's talk about the y-intercept, okay? This is going to be an important part of what we are looking at with the slope-intercept equation. So we know that, excuse me, on a coordinate plane, we have got these two axes. We've got the x, and we've got the y axis, okay? And so what we are going to be looking at is where our lines cross the y-axis, okay? And wherever our line crosses the y-axis, this is known as the y-intercept, okay? The line crosses the y-axis at the y-intercept point. This is important to understand this concept of the y-intercept, okay? And you'll see as we go along. So the actual slope-intercept form of the equation, slope-intercept form, we know what slope is. We just talked about this intercept, okay? It's that y-intercept right there, okay? The slope-intercept form of a linear equation is in the form of y equals mx plus b. And I promise you, if you memorize this now, it will save you so much heartache and trouble in the future, because so much of what we do goes back to this linear equation. We know that x and y represent points, okay? M is our slope. M is our slope, okay? And B will represent our y-intercept. And all of our equations that are linear can be put into this form. Can they all be put into that form? Yes. Blue-footed booby. See his blue feet. Does everybody see that? Oh, this way. Yes, blue-footed booby. All of our linear equations can be put into that form. Oh my gosh, can you show me how? Yes, blue-footed booby, I certainly can. Okay, we're going to go to another page because I'm going to work with a clean page. So first, we're going to look at just taking our slope and our y-intercept and putting it in. So let's say they tell me that I have a slope that my m is equal to 2/5, okay? And of course in our last section we learned how to find our slope, and our y-intercept is going to be -1. And now I can take this information and I can put it into my y equals mx plus b, and I can say that y is equal to 2/5 x. Okay, I'm going to do plus -1, okay? But what I do want you to kind of get used to doing is y equals 2/5 x minus 1, okay? These are exactly the same. This is how it will be presented to you most often, okay? This is how we learned it, adding the opposite, okay? This is how we're actually going to use it in reality, okay? Now, let's say we have a graph and we want to actually get an equation off of our graph. So now I'm going to build a coordinate plane and I'm going to put a line on it, and let's say my line is going to go here, and okay, let's do this line here. Okay, so here is my line, okay? So the first thing I'm going to do is I'm going to look for the slope of my line and my y-intercept. So I can see that my y-intercept is equal to 2. My line is going through y at this point, which is 0, 2. So the actual point is 0, 2, because 0, I'm not moving off of the y-axis, and then 2. So I say that my y-intercept is the 2, but this is the actual point of the y-intercept. Okay, now I'm going to look at my slope, and I'm going to say, okay, I clearly have a point here, so I'm going to look at my rise over my run. So my rise is 2, and my run, 1, 2, 3, 4, is 4. So my slope is rise 2 over run of 4, which is equal to 1 over 2 because we always simplify. So now I have my slope, which is m. I have my y-intercept, which is b, and I can make an equation saying that the equation of this line is y equals 1/2 x plus 2. And this tells me everything I need to know about this line. Now let's say I wanted to just verify a couple of points. So let's say I'm going to look at the point, let's say I'm going to just verify this point here. I'm going to verify that, and this is point 2, 1, 2, 3, 2, 3. Okay? So I'm going to put that into my equation and say 3 is equal to 1/2 times 2 plus 2. 3 is equal to, well, 1/2 of 2 is 1 plus 2, which of course equals 3. I've kind of got it going both ways. Okay? So hopefully that looks pretty good to you. Now, we're going to take it the other way, and we're going to take a linear equation and we're going to graph it. I think you're going to love this part. So we are going to graph y equals 3 over 2x minus 2. So the first thing I'm going to do is I'm going to build my coordinate plane. Okay, here's my coordinate plane. And I'm going to look at this and I'm going to say this is my M, this is my B, and B is -2. So my first point goes right on the y-axis at -2. And then I'm going to look at my slope. And my slope, of course, remember, is rise over run. So the first thing I'm going to do is I'm going to rise 3. Okay? And then I'm going to run 2. Now, this is where we're going to talk about negatives and positives a little bit, but notice that my slope is a positive slope, so my line must be a positive line. And here is my line. Now, before we had to build a chart, in order to be able to put this, make a line, okay? But here, all we need is the y-intercept and the slope, and we have a beautiful line. Okay, now, we talked a little bit about the fact that, our slope is the rise over run, and we've got negative and positive slopes. So before we leave, I'm just going to go through a little bit with a couple of lines and building them based on our y-intercept and our slope. So let's say this one is y equals, and let's do -3x minus 1. Okay? So I'm going to come here to -1, and now I've got a -3 slope. So my rise, and we can do this just so that we can see that, of course, with every whole number, we can put it over 1. I don't know if you can even see that. Can the blue-footed booby see it? Yes, he can. Okay, so we're going to rise 3, 1, 2, 3. But now we're going to run left 1 instead of right. And now that is what we're going to talk about. We're going to talk very quickly about our negatives and our positives. So this is the line that we have here. So let's look at a coordinate plane, and let's talk about how the coordinate plane works, just so that we can understand. Okay? We know that as with our number line, this side is positive, okay, and this side is negative, because this is 0, 0 here. Everything starts from the base, and anything going to the right is positive, and anything going to the left is negative. When we talk about our y-axis, okay, anything going up is positive, and anything going down is negative. So when we have a slope that is positive, there are 2 ways that we can go. We can go up, okay? Remember, we're doing rise over run, so we can go up, and then we can go right, because up is positive and right is positive. Or we can go left, we can go down, and we can go left, because down is negative and left is negative. So remember, a negative divided by a negative is equal to a positive, and a positive divided by a positive is also positive. So these are positive lines working with our slopes. So these are positive lines and our positive direction. Now if we have a negative line, we also have 2 choices. If we go up, which is positive, we have to go left, which is negative, okay? But if we choose to go down, which is negative, then we can go right, which is positive. In each case, the bird says we are not itchy. Okay, here we're going to have Mr. Googly Eyes watching over us. In each case, here I have positive being divided by a negative, which is negative, or a negative divided by a positive, which is negative. Okay, and this is how we develop these lines. Okay, make sure that you understand this, and please ask questions if there is something that you do not understand, because this is critical. This makes the difference between the line being drawn properly and the line being drawn improperly. So that is it for probably my favorite section of all time. So from all of us here, Mr. Blue-Footed Bobby, Booby, sorry, and Mr. Googly Eyes. Hello, Mr. Googly Eyes. Okay, have a great day.